Welcome back again. We are on page 74 of our INB, and we are going to go over what happens when we add or subtract a number inside of our parent function. So the first example we're going to look at today is the square root of x plus 3. I see my parent function in there. Parent function is just the square root of x, and I'm going to pick the key points today. Um, And these are a little tricky. They're not -1, 0, and 1, because you can't square root a negative number. And the first three perfect squares are 0, 1, and 4. So I'm going to pick those first three. Square root of 0 is 0, square root of 1 is 1, and the square root of 4 is 2. Graph those 3 points. And if I wanted to do 9, that square root of 9 is 3, just to get a better parent function picture. And this is my square root of x. Now what I'm going to do is I'm going to figure out my transformed points. But this time, instead of plugging in the same 3 points, I want to output the same 3 y values. So I'm going to have to think to myself, what number do I plug in for x to make 0 so that when I square root this, my output is 0. So I notice -3 right here plus 3 causes the number underneath the radical to be 0. So my x value is -3. Now I'm going to do the same thing, and I want to find what x value do I plug in, find out which one of these would x value would make my output a 1. So I notice if I plug in a -2 plus 3, I get the square root of 1, which is 1. So the next number is -2. And lastly, I'm going to look and I'm going to say, what x value do I plug in that's going to get me an output of 2, which means I want it to be the square root of 4. So I notice if I plug in 1, 1 plus 3 is 4, so I must input 1 to output that value. So now I'm going to look at my 3 points, and I'm going to plug them onto my graph and look at what happens. So I have -3, 0, and I have -2, 1, and I have 1, 2. Now look what it looks like. What happened here is that my function shifted left 3 units, back left 3 on all 3 of those points, which is a little bit different than what I might have thought, because I had a plus 3 added to the inside of the function and it went left 3. Let's look at our next function. Our next function is the 2 raised to the power of x minus 5. I notice that my parent function is the exponential y is equal to 2 to the x, or f of x. And I'm going to plug my 3 parent functions in, -1, 0, and 1. And if I plug, remember, anything raised to the -1 is going to cause it to reciprocate. So 1 over 2. And then I'm going to plug in 0. Anything raised to the 0 is 1. And 2 to the 1 is just 2. Remember, this parent function has a unique property, is that it has an asymptote, a place where the graph approaches. And so when I graph this, I want to make sure that I have a place for my exponential to land or approach. So there's my exponential, 2 to the x, that's the parent function. Now let's look at what happened. I have 2 to the x minus 5. Remember, we want our outputs this time to remain the same, and we want to see what we have to do to our x's so that we get the same output. So I want my power to come out to be a -1 on this first one. So what must x be? X minus 5 what must x be to get a -1? Well, it would have to be a 4, and then I would get 2 to the -1. So this is a 4. Now what would I have to do for it to become 0? It would have to be 5, because 5 minus 5 is 0. It would have to be 5. No. And then my next one, what does it need to be 1? Well, it needs to be 6. 6 minus 5 is 1. So now my x's have changed to 4, 5, and 6. Those are the x values that I plug into 2 to the x minus 5 to obtain the exact same y values. Now I'm going to graph those. 4 to the half, 5 raised to the, 5 comma 1, and 6, 2. And this is 2 to the x minus 5. So it looks like it got shifted 1, 2, 3, 4, 5 units to the right. Same as last time. The number said -5, but it got shifted to the right 5. So now I'm ready to create or state my transformation. So when we add or subtract a number to the inside of the function, it has a horizontal, meaning left or right, transformation. And we're going to say this has an opposite sign relationship, meaning it's going to go the opposite direction than the sign. Whereas the vertical one had the same sign relationship. So we'll practice these and get these down packed.